Hello friends, welcome to today's tutorial. In the previous tutorial, we saw what is the controller broker, where we learn about how one of the broker in the Kafka cluster is chosen as the controller and what is the responsibility of that controller broker. Today, we are going to learn about Kafka delivery semantics, in which we will see what is producer delivery semantics and what is consumer delivery semantics. So, producer delivery semantics. As we know, the producer writes only to a leader broker and the followers replicate the data. We already know that producer only publish the data to the leader broker and rest of them is act as a followers and replicate all the data from the leader. So how can the producer know that data is successfully stored at the leader or the followers are keeping up with the leaders? So that is the thing, like how the producer get to know that the data which the producer is publishing is successfully stored at the leader site. So the Kafka offer three options to donate the number of brokers that must receive the records before producer considers the write as successful. So there are three options provided by the Kafka which give the guarantee to the producer that whatever the message published by the producer on the Kafka broker is properly get written to the brokers or to the leader brokers and the followers. So let us see. The very first thing we have the async, then we have the committed to a leader, and the last we have the committed to leader and quorum. So what is async? Producers send a message to Kafka and does not wait for acknowledgement from the server. This means that writer is considered successful the moment the request is sent out. So this approach we called fire and forget approach that gives the best performance as we can write the data to Kafka at network speed. But there is one problem. There is no guarantee that that can be made that the server has received the record in this case. So that is the problem here. You can achieve the best performance, but there might be some message get lost. So in this case, once the producer publish or send the message to the Kafka broker, the producer assume that that message has been successfully published and written on the Kafka broker, and it will forget about that message. Like producer get forget, and this approach we called fire and forget approach. The another approach we have committed to leader. In this case, producer wait for the acknowledgement from a leader. This ensures that the data is committed at the leader and it will be slower than the async option, the first one option, as the data has to be written on the disk on the leader. So under this scenario, the leader will respond without waiting for the acknowledgement from the follower. So in this scenario, once the message get published to the leader, then leader will send the acknowledgement to the producer that message has been successfully published. But the leader will not wait for the followers responding. For all the followers that it might be possible that follower not able to duplicate or replicate the messages which is get present in the leader. So in this case, the leader will not wait for the followers. It will directly send the acknowledgement that to the producer that the message has been successfully delivered. So in this case, the record will be lost if the leader crashes. Okay, so that is the problem. If the message get published to the leader and suddenly leader get crashed and the follower is not able to duplicate all the message, so in this case the message will get lost. The third option is committed to leader and quorum. Here, producer wait for acknowledgement from the leader and the quorum. This means that leader will wait for the full set of in-sync replicas to acknowledge the records. So here in this case, the leader will wait for the follower to get the acknowledgement that all the message is replicated in all the followers broker. So this will be the slowest write, but guarantee that the record will not be lost as long as at least one in sync replica remains alive. This is the strongest available guarantee. So this is the strongest option where you will not lose the data. It gives the guarantee that data is present or successfully written in all the leaders and the followers. But there is the performance issue compared to the other two above options. Now, as we see, the above options enables us to configure our preferred trade-off between the durability and performance. So if our requirement is like that, if we would like to be sure that our records are successfully stored in the Kafka, then we have to go with the last option, that is committed to leaders and the quorum. But if we value the latency and the throughput more durability, we can choose one of the first two options, and these options will have the greater chance of losing messages but will have the better speed and throughput. So this is all about producer delivery semantics. Now next we will see the consumer delivery semantics. A consumer can read only those messages that has been written to a set of in-sync replicas. There can be three ways of providing the consistency to the consumers. So as you know that consumer can only read the messages that has been written to all set of replicas along with the leader partition. So here to achieve the consistency, there are three options we have: at most once, at least once, and exactly once. So what is at most once? Messages may be lost but are never be redelivered. In this option, message is delivered at maximum of one time only. Under this option, the consumer upon receiving the message commits or increment the offset to the broker. Now, if the consumer crashes before fully consuming the message, that message will be lost as when the consumer restart. It will receive the next message from the last committed offset. So in the first option, once the message get consumed by the consumer, then it increment the offset number on the Kafka broker. But the problem is like that when it get crash, then it will lose the message because it already increment the offset number on the Kafka broker. So when it again restart, then it will start consuming the next message from the Kafka broker. So earlier message will be completely lost. The second option is like at least once. Messages are never lost but may be redelivered. So under this option, message might be delivered more than once, but no message should be lost. This scenario occurs when the consumer receives a message from the Kafka and it does not immediately commit the offset. So at this option, what is it give the guarantee that message will not be get lost. So what happen instead of it wait it till the complete the processing. So in this scenario, once the consumer receive the message, it will do all the processing and then perform the commit operation on the Kafka broker. So once all the processing is done, then the commit is going to happen on the Kafka broker. So in this case, if the broker get crash between that processing after consuming the message, then still that commit has not been performed on the Kafka broker. So there is again once it get back online, then it will start consuming the same message from the Kafka broker because there is a no commit happen on that Kafka broker. So if the consumer crashes after processing the message but before the committing the offset, it has the reread the message upon restart. So since in this case the consumer never committed the offset to the broker will redeliver the same message and thus duplicate message delivery could happen in such scenario. So that is one problem here. You this keep the guarantee that message will not get lost, but there is a chances of getting duplicate message in the consumer side. So what will happen? Suppose the consumer consume the message and it start processing it. And once the processing done and suddenly it get crash and it not able to commit on the Kafka broker. So once it will come back online, then it will start consuming the same message because commit does not happen on the Kafka broker, and it will get the same message again and it will process the same message. So there is chances of getting the duplicate message. Now let us see what is third option we have. Exactly once. So each message is delivered once and only once. It is very hard to achieve this unless the consumer is working with transactional system. Under this option, consumer put the message processing and the offset increment in one transaction. So both the things is happening in the one transactions. Like it put the message in the processing as well as it also performing the offset increment in the Kafka broker. So this will ensure that offset increment will happens only if the whole transaction is complete. If the consumer crashes while processing, then the transaction will roll back and the offset will not be incremented. So when the consumer restart, it can reread the message as it failed to process it at the last time, and this option leads to no data duplication and no data loss but can lead to decrement throughput. So the third option is more good because it guarantees that you will not get the duplicate message as well as you will not lose the any of the message when the consumer get crash. The reason being is that both the things like commit and the processing is happening in the single transaction. So once any of one of them get failed, then transaction will be re-back or rolled back, so that when the next time the consumer restart, it will start processing again for that message, both the things. So that is all about for today's tutorial. We have learned about Kafka delivery semantics, where we saw what is producer delivery semantics and what is consumer delivery semantics. In the next tutorial, we are going to see some of the Kafka characteristics and we will bind up it. So thank you so much for watching this and bye.